In Chapter 4, we will be doing antiderivatives and indefinite integrals. So in Section 4.1, we'll be introduced to antiderivatives. So your goals for this sections are to write a general solution for a differential equation and use the definite integral notation for antiderivatives. And second goal is to use the basic integration rules to find the antiderivative, and then find a particular solution for a differential equation. So let me introduce you to the definition of antiderivative. Antiderivative is when a function f, the capital F, is an antiderivative of f, the small f, on the interval I when f prime, the capital F prime of x, is equal to f of x. So if the derivative of the capital F of x is little f of x, then f is the antiderivative. Now let me go over some antiderivative notations. So antidifferentiation is same as the word indefinite integration. So these two are interchangeable. This is a notation for integration, where this symbol is your integral notation, which means take the antiderivative. Okay, so I would normally use this and say take the integral of f of x with respect to x. So f of x dx. F of x is the function that you're going to be taking the antiderivative. It's called the integrand, and dx represents the variable of integration. So that means that you're taking the integral of f of x in terms of x. So then the answer to that integral will be your capital F of x, because f of x is your antiderivative of f of x, and then plus c. There will always be plus c, the constant of integration, because when you take the derivative of a constant, that derivative becomes 0, so that c goes away. So depending on what your initial condition is, that c will change. Now the basic integration rule is on page 250. So I'm not going to list all of them right now. We will talk about this on Tuesday, on the next day. But all the rules are there. So if you notice, the integral of f prime of x dx is this, f of x plus c. I'm going to tell you right now that the integral, which is the antiderivative, if I am given the integral, and if I ask you to take the derivative of the integral, these two are opposite operations, and your answer would be just what the integrand was. Okay, so let me get through some examples with you guys. So I'm going to use example number 8. Or number 8 in your problem set. It says find a general solution. So what we're going to have is we're going to start with dy dt. This is a differential equation, and that is equal to 5. And we're going to rewrite this differential equation into differential form. So once we rewrite it in differential form, we're going to say take the integral, or find the antiderivative of this. Well, the antiderivative of dy is y, and that is equal to, and the reason why I put the 5 outside of the integral is because of one of the basic rules. You could pull out the coefficient, pull that out, and take the integral of dt with respect to t, and the integral of dt will be then just t plus c. And this is the general solution of this differential equation, dy dt equals 5. Now I'm going to do example number 11. I'm going to rewrite this, and I'm going to rewrite this as integral of x to the 1/3 dx. Now remember, when we took the derivative of a power, what we did was we brought down the exponent and we subtracted 1. In this case, what we're going to do is we're going to add 1 and divide by the new exponent. So this becomes x to the 1/3 plus 1 divided by 1/3 plus 1, which is your new exponent. and then that becomes, so plus c, so then this final answer, this is 3 over 3, so then this becomes x to the 4/3 divided by 4/3 plus c. Then I could rewrite this as 3 over 4 x to the 4/3 plus c, and this is the antiderivative of this integral. Here's number 12. I could still rewrite this again. I'm going to do the antiderivative, and this becomes 1 over 4 x to the negative second power with respect to x. So what we're going to do is we're going to pull out the 1/4 and just integrate x to the negative second power dx. Now, using the power rule, we're going to add 1 and divide by the new exponent, which makes it 1/4 x to the negative 1 divided by negative 1 plus c, which then becomes negative 1 over 4x plus c. And that's your antiderivative. Alright, let's go through some of these now. And we're going to integrate, and we're going to check by differentiating. So now one of the other basic rules for integration is this. You're allowed to separate this into two separate integrals, 13 dx minus the integral of x dx. Now this is a coefficient, so we're going to pull it out. So we're going to pull it out, and the integral of dx minus integral x dx. Now, integral of dx is just x, so 13x minus, using the power rule, this becomes x to the 1 plus 1 over 1 plus 1 plus c. Then this becomes 13x minus x squared divided by 2 plus c, and this is the integral of this function right here. So this will be my y, or f of x. So now if I were to take the derivative, find the differential of this, the differential of this will be dy is equal to, we're just going to take the derivative of this, which is 13, and bring down the 2. 2's will cancel out, so this will be minus x. And then remember, the differential is the derivative times dx, and this is what I end up with when I started there. Okay? Now, here's an interesting one. Because integration doesn't have a product rule or quotient rule like derivatives, what we have to do is rewrite this and separate into three fractions. So this becomes x to the 4th over x to the 4th minus 3x squared over x to the 4th plus 5 over x to the 4th dx. And then if I simplify this, what I get is 1, and I'm going to pull that out. This will be 1 dx minus integral of 3 over x squared dx plus 5 over x to the 4th dx. Separate the integrals. So then I could rewrite this as the integral of dx minus the integral, and I could pull the 3 out as well. Let's pull the 3 out, and then we're going to integrate and rewrite this as x to the negative second dx, and then this will be plus 5 and integral of x to the negative 4 dx. So now the integral of dx is just x minus 3 times, now if I add 1 and then divide by, so this will be x to the negative 2 plus 1, divide by the new exponent, negative 2 plus 1, plus 5, same thing, x to the negative 4 plus 1 over the negative 4 plus 1, and then I got to have my plus c, the constant of integration. So this simplifies to x to the negative 3, x minus 3, and this will be x to the negative 1 over negative 1 plus 5 x to the negative 3 over negative 3 plus c. And if I want to rewrite this and make it look pretty, this becomes x this makes it a plus 3 over x, and this makes it a negative 5 over 3x to the third plus c. And that's the integral of that function up there. Now I have a trig function. This is example from number 34. What we're going to do is I'm going to distribute this in and distribute that in. So when I distribute, I get integral of secant of y tangent of y dy minus the integral of secant square root of y dy. Now remember, you got to think about what function has the derivative of secant y tangent y. Well, the derivative of secant is secant and tangent, so this integral of this just becomes the secant of y minus. Now if you think about the secant squared of y, well, the derivative of tangent is secant squared, so this is just tangent of y plus c. And this is the integral of that function. Now we're going to talk about initial conditions and particular solutions. So first we're going to do is we're going to find a general solution of this right here. So if I want to integrate, what I'm going to do is integrate this. So the antiderivative of this is given by, we're going to rewrite it as x to the negative second power, and then when we integrate this, we're going to add 1, and then we're going to subtract, add 1, and divide by the new exponent. So this becomes, and then you got the plus c, and so this becomes x to the negative 1 over negative 1 plus c, which is then negative 1 over x plus c. So this is the general solution to this function. So this is the integral or antiderivative of 1 over x squared. So now I want to find a particular solution. That means that I want to know what that c is. So this will give me, so my initial condition will help me find that particular solution, what that c is. So if f of x is equal to negative 1 over x plus c, and at x equals 1, y value is 0, is we're going to set this y value equal to 0, and we're going to plug in 1 for x. And so then this will become 0 equals 1 negative 1 plus c. I'm going to add 1 to both sides, so then c has to equal 1. So then my particular solution is f of x equals negative 1 over x plus 1. Oops. And that is my particular solution right here. Very last example that I have that we're going to be covering in this section is we're going to be solving a vertical motion problems. So remember, if they give you a position function, the derivative as prime of x would be the velocity, and then the derivative of velocity, which is the second derivative of the position function, is acceleration. So what we're going to do is we're going to go backwards. So given the acceleration, we're going to find the position function. Okay, so it says ball is thrown up with initial velocity of 64. So at t equals 0, velocity at 0 is 64 feet per second. And and also the position at 0, the initial position at 0 is 80 feet. So those are my initial conditions. Now, I have acceleration of 32 feet per second squared. given this, I'm going to find the velocity. Well, velocity is the antiderivative of acceleration. So what we're going to do is we're going to rewrite this as a of t equals negative 32 dt. So let's do this. Or we can say dv, the velocity. Okay, so we're going to integrate both sides. So integral of dv velocity is, so maybe I should say this is equal to dv dt. So then we're going to separate that over, and then the integral, you keep the negative 32, and integral of dt is just t plus c. Well, the initial velocity is here, so at t equals 0, the velocity is 64, so I can say that the v of 0, which is 64, is equal to negative 32 times 0 plus c. Then the initial velocity has to be 64, so that's my c. So then the velocity, the particular solution of the velocity is given by negative 32t plus 64. So now I'm going to find my position function. Well, velocity is the derivative of position function, so I'm going to rewrite this as the ds is equal to negative 32t plus 64 times dt. So now what we're going to do is we're going to integrate this. Well, integral of ds is s, which is our position function. And that is equal to, now we're going to separate negative 32t dt plus the integral of 64 dt. Now we're going to integrate this, which is negative 32 comes out, and integral of t dt, and then we're going to pull out the 64 and integral of t. Now we're just going to use the power rule here, so I have 1 plus 1 is 2, so I'm going to divide by 2, so this becomes negative 32 t squared divided by 2 plus integral of dt is just t plus c. This is my s of t. Now, given our general solution, we're going to use s of 0, which is 80 feet, and to find their c. So this is equal to, the height is at 80 when t is equal to 0. So c has to equal c. So a particular position function will be then negative 32t squared over 2 plus 64t plus 80. So if I resimplify this, the position function then is negative 16t squared plus 64t plus 80. And this is a particular solution for the position function given the acceleration of negative 32 feet per second squared. I will go over more of this on Tuesday. If you need extra help, we will discuss this on Tuesday, and maybe we'll spend an extra day going over the basic integration rule.